Hi friends, welcome to this session of DevSecOps, which is an overview on the security integration to the DevOps pipeline. My name is Joy and I am a system architect. The reason I wanted to go with this kind of a presentation or maybe a session on DevSecOps is because we all know DevOps means a union of development and operation process. But it's very important to integrate the security part in this whole DevOps pipeline too. So with looking into that particular picture, it's very important to understand what exactly is involved into the DevSecOps process. How we can implement the security, how we can integrate the security. Those are some of the important parts of the whole pipeline that needs to be done. So let's go ahead with this. However, I want to just highlight the plan that I want to do it. So this particular session, it's just going to give you an overview of DevSecOps. It's not going to go to the depth of it. However, my plan is to add many more sessions on in-depth level of understanding how we can implement it. So that means that we are going to use some of the tools. We are going to create some of the proof of concepts, use some of the tools, security tools in the DevOps pipeline, and see how that works out. So this is going to be a series of sessions, and each of the session will cover. We'll try to cover each of the session with multiple implementations. All right. So let's get started. So we know the DevOps release pipeline, right? It is a continuous integration. We have a continuous delivery, and then we have a continuous deployment. Pretty much that's what it is. Now, when we are integrating the security part to it, it needs to be integrated in each phase of this particular pipeline. What are the phases of the DevOps? We have plan, we have code, we have the build, test, release, and deploy. So in each phase, we are going to implement the security. We are going to integrate the security to it. Now, for doing that, one of the important things that we have to also understand is when we are trying to plan kind of a process like that, it's very important that we have someone who is going to take the whole responsibility and can play a role in order to provide that kind of an implementation. So let's say that we can have an on-site security advisor role. So what's his major contribution would be like, he's going to anticipate the potential security risk. He's going to work on the risk analysis, right? He's going to look into some of the security requirements that is required for the development phase. It depends on project by project. It depends on different kind of parameters. He's going to articulate some of the security phase updates, some of the compliance that is required, like the policies that needs to be implemented as part of the DevOps pipeline. And also he's going to provide some of the reference architecture, application, infrastructure code, and some of the common components. So an advisor, an on-site security advisor, is very much important in order to play a vital role in this particular implementation. So if we are looking forward towards the DevSecOps adoption, then there are various steps. Okay, there are various steps that needs to be followed. First, we have to go through a security scan for all the CI/CD workflows that we have, right? Second thing that we have to also ensure is the code quality and the security that needs to be done with the static and the dynamic scans or the analysis. The third part is the monitoring of the continuous process, whatever is happening in the CI/CD pipeline, in the release pipeline, that needs to be monitored. Okay, and the fourth step is to get an adoption of the everything as a code, like infrastructure as a code, policy as a code, pipeline as a code. Everything should be as a code. Okay, so there are we can divide this into 4 different stages of DevSecOps adoptions. Let's start with the first thing, which is the continuous assessment. Okay, what is a continuous assessment process? So the major part in the continuous assessment process that happens is we need to set some processes which can look into some of the benchmarks, some of the industry standards that can identify the vulnerabilities, and that can establish a particular kind of an analysis or a report which can tell that these are the set of standards that needs to be followed for the vulnerabilities that is coming up. Okay, so there are a lot of things that needs to be followed over here. The first thing is we need to identify the top 10 vulnerabilities that we have with the open source foundation application security. So this is a principle of OWASP. If you go to OWASP, you'll find a lot of principles and the process that is involved in order to find the vulnerabilities. It will give you the list of vulnerabilities that is already there. Okay, so first we have to figure out what are the type of vulnerabilities that can come. Okay, the second thing that we need to figure out is that we need to implement is the Azure Security Center's regulatory compliance dashboard. Okay, if you're moving into the Azure, that's pretty much important to look into to implement that particular security center. And we have to see or monitor the dashboard over there to scan the vulnerabilities that is provided in the subscription. All these vulnerabilities need to be to go through some of the compliance readiness, which is the part of the CIS benchmark or NIST framework. So if you look into the NIST framework and the CIS benchmark, these are kind of cybersecurity framework and the the security benchmark that needs to be followed by each of these processes. So a comprehensive vulnerabilities needs kind of process needs to be followed over there. So we need to make it compliance readiness. All right, the process also involved the scanning of the container images. Now containers is kind of an implementation that we are looking into for a modernization aspect. So obviously each of the images that has been deployed needs to be scanned properly to find out if there are any kind of security vulnerabilities involved in those messages. In the images, right? So the scanning of those container images is very important. The second thing is very important is infrastructure as a code. Now, whatever the infrastructure you are building in the cloud environment, maybe it is in Azure, AWS, or Google, it doesn't matter. It's important to follow the infrastructure as a code process. That way, the whole infrastructure can be scanned properly, and we can integrate some of the security tools in order to scan some of those infrastructures. Okay. We need to build an automated process which can scan some of the changes that occurs in the in this particular process also, right? So that is very important. We have to get a report of any kind of issues or any kind of vulnerabilities that is found in the whole pipeline of the process. So in order to do that, we have to use some kind of a trend analysis to improve the traceability of those particular vulnerabilities or the security breach that is happening. We need to also generate some of the reports for the duplicate code, because one of the things that is very important is when you are deploying a particular application to any environment or any deployment environment like production or something, the most important thing is the code. That's the framework, right? So the code is if the code is a low-level code, if it is a duplicate code, there is a chance of a lot of vulnerabilities to happen, right? A lot of security breach can happen. Object undefined, some of the objects that are not used, variables not used, code that is duplicated multiple times. They are all the loopholes. They are all the points through which a security can be breached. So that is something that needs to be analyzed. And of course, we do the check-in, check-out process with our source code repository version controls. So there we have to have the security gate to measure the code quality. Okay, so there are multiple steps that needs to be followed as part of the continuous assessment process. One, we have to identify the top 10 vulnerabilities as recommended by OWASP. So if you go to the OWASP guidelines, you will find top 10 vulnerability. So identify that. Second, you need to ensure that there's your security control, right, which is our center, which is implemented over there, that will give you a compliance dashboard. All right. Third, get to know the NIST framework or the CIS benchmark protocols, because that is very important in order to place those protocols or implement those protocols as part of your pipeline. Okay. Fourth, scanning of each of the container images and implementation of infrastructure as a code. That is an adaptation again, because most of this is again, one of the thing is an adaptation to DevOps, adaptation to DevSecOps is a change process that needs to be adapted. Okay, so those things needs to be done. The fifth point is automate the build processes. Okay, and also find out the different changes or get a kind of a traceability of whatever the changes or updates is happening. Sixth, get a report, find a trend analysis audit report for that. Seven, we need to generate reports of different duplicate codes or low-level code that is part of this particular application software code base. And the last one is implementation of security gate to measure the code quality against those standards that we have been implementing as part of the pipeline. So these should be as a part of your continuous assessment process. Okay, these are the different steps that needs to be part of your continuous assessment process. So Azure gives one of the security dashboard. If you look into the security dashboard, it has the subscription level security. It has the intelligence to look into some of the test cases, and it will test the verification part. It will have a secure way of deploying the the CI/CD pipelines, the release process. It will periodically scan some of the production, and it will watch for all those particular security breach that is happening. There's a log analytics that is used for alerts and monitoring of your DevOps stages, and you can use the data-driven improvements for the security, which is the cloud risk governance. So there is a DevSecOps kit that is provided by Azure itself, which will have all these different parts of the security integration to your DevOps pipeline. The next thing that we have to understand is the static and dynamic scans. So one of the things that static and dynamic scans is very important to look into is because you have different type of application. You have a static application, you have a dynamic applications. And it's pretty much important to understand that what are the different types of scanning processes that needs to be involved in for the different kind of applications. So there is a language, there is a coding language or I would say a pipeline, language kind of thing, which is called the code QL, which is which is a kind of a vulnerability tool that can be integrated to the GitHub or the source control versions that can actually find out different kind of vulnerabilities from your source code base. That is the first thing that we have to do. All right, we have to figure out that when there's a particular check-in and check-in process is happening, what is the different kind of, what is the code that is going in, and what are the vulnerabilities that is getting us part of that particular check-in process. Dependency checker is another part of the CI pipeline, which scans the different kind of dependencies. Every code base, right, every application that you are building, every code base that you are building has dependencies involved. It can be framework related, it can be third-party dependencies, it can be third-party services, APIs, libraries, DLLs. So dependency checker is going to actually pull out the CI and the assets that is part of the check-ins, and is going to look into some of the dependencies. It will scan those dependencies. It's going to scan the containers for image vulnerabilities. It's going to scan, we need to scan the infrastructure by adopting the SAST approach, which is the static application security testing. And that adoption is going to be using the infrastructure as a code. As I have already mentioned that, I'm going to go through different phases of these sessions. So this is not going to be one single session. There will be multiple sessions. Each of these implementation, the infrastructure as code, the security testing, how we can identify the vulnerabilities in the containers, images, how we can implement code QL, how we can do the dependency checkings. I'm going to try to prove, create some of the proof of concepts and, share the POCs with you so that you can have a look into that and, get a kind of an understanding of how this works out. The dynamic application security testing is the DAST in the CD pipeline, which identify the security breaches in the environment. So there are two types of things. One is a SAST, another is the DAST. Okay. So you are scanning the infrastructure in the SAST, which you are doing using the infrastructure as a code. And the another thing is you are actually scanning the environment where it is getting deployed, right? So that is done by the DAST. The comprehensive analysis tool will provide you some of the vulnerability code that is part of this process. So static and dynamic scans are pretty much important. The steps that you are following is you are using a kind of a language tool or vulnerabilities scanning tool like CodeQL as part of your GitHub integration. You are using a dependency checker to check or scan the dependencies that is part of your code base. You are scanning the container images for all the vulnerabilities involved. You are scanning the infrastructure. If you are doing an infrastructure as code, you are scanning the infrastructure as code, right? You are scanning the infrastructure that is getting deployed. And then you are scanning the deployed environment where the infrastructure and the application is getting deployed using the DAST, right? And the last part is you have a whole report of, a comprehensive report of all the vulnerabilities that is involved as part of this process. The third thing that is very important is to have continuous monitoring process. So what I mean by monitoring, when you are developing the application, that's fine. When it is deployed, when it is running, the environment that where it is running, the infrastructure that is running this particular piece of code, the code that itself is running, right? All these major parts needs to be monitored perfectly. And it has to go in a way that there should not be any security breach, there should not be any vulnerabilities as part of the production, right? So to do that, we need to gather some of the holistic data of this particular thing. We have to do a structured data analysis for this particular monitoring process. There should be actionable threats and intelligence that needs to be kind of a provision which will come to the users. I mean, as part of the development team or architects or whoever the sole responsible use cases are. They need to be informed about the threats and the actions that needs to be taken. And we need to incorporate some of the robust monitoring toolchain. So to do that, there are a lot of tools. You can use the machine learning trend analysis, which is kind of going to give you a report on different kind of events that is happening, the vulnerability events, some of the security breach that is happening. It's going to give you some of the insights on that. You can have a threat intelligence tool, which is going to give you information about the user who is hooked into this particular systems or that particular space. It's going to give you the information about the device, the IP address from where it has logged in, the type of device it has used in order to log into that particular space, the last updates that has been done as part of this particular process. Then you have the Azure Security Center, which is going to identify the security threats and it's going to give it to you. You get an Azure Defender, which will protect all the workload that can be a threat, that can be exposed to those security threats. The Azure Sentinel is going to provide the security information, and it is going to automate some of the environments. Okay, and you have Azure Arc, which is basically going to provide some kind of a visibility in operations and compliance across the resources. Cool. So continuous monitoring is pretty much important. So you started with a continuous assessment, right? And then you had a static and dynamic scanning process, right? And the third steps that you are following is continuous monitoring of the application, the infrastructure, the environment, everything. Everything as a code adoption. It's very important. Industry is right now moving towards that direction. Everything should be as a code. It's not only your code that is going into these particular environments. It's not only your code that is getting deployed to the environment. You need a code for your infrastructure. You need a code for your pipeline that you are building. You need a code for your configuration that is part of your infrastructure. You need code for the policies, right? What I mean by policies, like you are implementing some of the compliances or some of the policies like role-based access control, RBAC, all those kind of stuff, right? So you need to have all those information, all those bits and pieces as part of code, not done manually. Everything should be automated process, right? So for that, there are various kind of tools you can use. Terraform is one of the tools that is developed by HashiCorp, and which is used typically to create, change, or improve the infrastructure. Terraform is widely used by the industry, and it's recommended to use Terraform in order to build your infrastructure as code. You can use for Azure automation also, and you can see how that works, but I would recommend Terraform. The Azure Image Builder can be used in order to automate some of the base images, creation of the base images with the configuration, with dependencies, with framework and applications. And it's very ideal for immutable infrastructure. What I mean by immutable infrastructure is there should not be the process that needs to be followed, or the the behavior that needs to be followed is that if there is a kind of a change that needs to be done, you should not go ahead and update the VM. Rather, create a new VM out of it. Okay, because when you are trying to update a VM, if there is a change in the infrastructure or something, like if you're trying to update that VM, properties or something like that, what's going to happen is there's a pretty much big amount of chance that it's exposed to the vulnerabilities or the security threats, because the VM is exposed to the internet. So instead of doing that, deprovision that VM, demolish that VM, and then reprovision another VM out of that. So infrastructure as a code will help you out to do that a lot. The OS automation tool can be used for configuration management. For example, Ansible is one of the OS automation tools that can be used for configuration management and the application deployment. It's basically written in environmental language, and you can use that, right? So that's what we need to move into. Everything should be as part of code. The policy, infrastructure, configuration, pipeline, everything should be as code, right? So if you see the policy automation, the next step that is very important is the policy automation. So as I have already mentioned, the policies can be anything. It can be your RBAC processes, RBAC policies, rules, which you are defining there. It can be policies that is very much compliance to the government, right? ISO standard, PCI, DSS, CIS, benchmarks, NIST frameworks, cybersecurity policies. So you can have all these guidelines or all these requirements as part of your Azure blueprint, which will be set up as a part of your baseline, right? So you first determine your policy set. Second thing that you do is you code those particular benchmarks, those particular policies, and you version those particular policies in GitHub or any kind of source control version repository, source control version 2. We typically go for GitHub, right? So you can put it over there. Then you update those policies in code, right? Nothing is updated manually. Everything is done through code. You update the policies in code. You have different version of those policies in your GitHub because that's the version control system. You push these policies to the Azure, right? Now you add another policy, another standard, or another requirement. You update that particular policy. You have a new version of that policy. Then you publish that particular policy, the new version of the policy, to Azure, right? So that's an automatic push that you are doing. Then you are going through a compliance scanning process of this policy, right? Whatever the compliances you are putting as part of your policy, that needs to be scanned. You use the quality gate, for example, the policy agent that is there in Kubernetes can be used to check, the kind of the quality that is part of this particular policy. And then you use the Azure Security Center to monitor the compliances telemetry, right? You get a real-time telemetry out of that. You see what are the security vulnerabilities over there, if there is any threats, or if there is any threats that has been that has moved into. So that's a whole policy automation that you need to do. Dependency management is pretty much important whenever you are writing a piece of code and you are deploying it to a new environment. You're publishing this particular piece of code. There are many dependencies that goes with the code. So it's pretty much important to scan those dependencies for any kind of vulnerabilities, right? The DLLs, the libraries, the frameworks that is part of that particular code needs to be scanned. You update those dependencies, you take control of the dependency usage. One of the most important things that is very much required to understand is we have to remove the circular dependencies or any kind of conflicting dependencies that is happening. So dependency management is pretty much important as part of your SecOps pipeline. Okay. So having said that, now you know that these are the different stages of the development, the DevSecOps pipeline. So the first, the the continuous improvement thing that you are doing, right? The assessment part. The second, which you are doing, is the automating everything. You are doing the monitoring. You are doing everything as code. You are following some of the benchmarks, some of the compliances that is part of this process. You are scanning the dependencies. You are scanning the vulnerabilities that is part of the dependencies, and you are automating the policies as part of your process. So you are setting up stages by stages or phases by phases for this DevSecOps implementation. All right. Now, just to give you an overview, this is one of the implementation phases. How it looks like: you have a plan, release, deploy, monitor, respond, test, and build and code, right? So you code, then you plan, you release, you deploy, you monitor it, you build it, you test it. So these are the different phases that is part of your DevOps pipeline. Now, each of these phases, there is a considerable amount of security threats that can be integrated, that can be part of these particular phases. For example, like code, right? When you are doing some kind of an you are checking this particular piece of code to the security, to the source control version. There is a very much there can be like some kind of threats or vulnerabilities that can be exposed as part of the check-ins. Planning, change cases, the change impact, and threats that is part of the planning. Releases, right? You are accessing and configuration management. So that's the configuration management is also part of where the threats can be there, vulnerabilities can be there. Deployment, where you are deploying. Monitoring is part where you are monitoring everything. You are responding to every kind of attacks that is happening. You're testing the type of authentication, the SQL injection, and everything over there, right? So each of these phases has pretty much exposed to the threats, pretty much exposed to vulnerabilities, right? So what are the tools that we can use? So what I'm giving over here, what I'm trying to share over here, is some of the tools that you can use in each of these phases. So plan phase means what, right? You are basically, the plan phase has some of the key components of the plan phase is collaboration, collaboration in the team, discussion, reviewing the security analysis, right? Strategizing the security part that needs to be part of this deployment process. So that's what the plan phase is. And there are various kind of tools that you can use, like for example, Jira, which is used as a kind of a release software where you can plan and track the different kind of actionable items, the data that needs to be part of your software deployment process. Slack is a communication tool that can be used in order to enable the team to communicate with each one another. There's a threat modeling platform called Ideas Deals Risk. Some of the tools I have never used, like Jira and Slack, I have used a lot, so I can say that they are really effective tools. Ideas Risk I have never used, but what I'm trying to do over here is I'm trying to share those tools. Maybe if we get some time, we can use some of these tools and see how they really work. I'm not going to go for a paid version, but if I get a trial version of some of these tools, I can use this trial version, create a proof of concept, and actually share that with you guys. So these are some of the tools that can be used as part of the plan phase security. The second phase is the code phase security. So the code phase security means you have the static code analysis, you have the code reviews, you have the pre-commit hooks. In code phase securities, you have different kind of tools that you can use. Various spot bugs, PMD check style, find security bugs. Pretty cool tools. I was going through some of these tools. I never used that again, but based on the guidelines, based on the documentation that their pages have, it's pretty good tools. You can actually try some of those tools. I'll of course try some of them, right? For example, PMD, it's a source code analyzer tools. Even you are using SonarQube or something like that, right? You can use Spotbox for static analysis for Java code. .NET code can be different, so you have different kind of codes, right? Coding language. So static analysis can be different for different kind of coding language. So you have to find the proper tool that can be used for that kind of analysis. The Garrett is Git enable code review for the source code. Check style, if it gives you a platform for having those coding standards, and the security audits is done for Java web application by Spotbox. So these are basically Java. It seems like most of them are Java kind of thing, but I would really be interested to look into some of those which can be used for the .NET, C#, Python kind of tools, right? Build phase security is very important because that's where you are scanning the external codes that is part of your dependencies, and you are actually trying to figure out if there is any kind of security vulnerabilities as part of the dependencies, right? So you are doing the software component analysis, you are doing a static application software testing, SAST, which I have explained to you before, and you are doing unit testing. There are a lot of tools that you can use: OWS dependency check, SonarQube, SonarClear, Retire, Checkmarks, Sync. SonarQube I have used. It's pretty good tool. You can actually fix some of the code vulnerabilities by running that particular tool as part of your DevOps pipeline. You basically integrate the SonarQube in a check-in process, and it runs the unit test cases, and it will also find out some of the vulnerabilities that is part of the code, and it will provide a detailed report about it. One of the thing that we always follow is there should be a benchmark before that particular check-in code get merged to the main branch, because whatever you are working on, you work on a feature branch, right? You don't directly work on a master branch or the main branch or the development branch, right? So you work on a feature branch, you work on a feature, you create a feature branch, you work on that. Once that feature is done, you merge that code to the development branch, which goes to the master branch for staging, right? Environment. Now, what I mean by staging is the test environment, right? So before it gets merged, right, you run the unit test cases, and you create a benchmark that at least 95% of the test cases should be executed and should run properly. You integrate the SonarQube in order to fix the code vulnerabilities that is part of that particular code checking, and also you identify what are the gaps that is there. You do the quality gate checking, right? Once that is done, then only this particular piece of code get merged to the development. Otherwise, it doesn't go there, right? That's the process that we typically need to follow as part of your CI/CD pipeline. CI, typically. The test phase security, it's very important again to follow some of the test phase security, like the user authentication test, authorization test. Look for the SQL injection, API endpoint security test, penetration testing, and everything you are doing. So there are a lot of testing phase that needs to be part of these test phase. The security testing that needs to be done, and that's where the test comes into picture. BDD, automated security test, calls, SecApp Suite, OWSP, ZAP, Archini. These are some of the test phase security tools that can be used. Again, I have not used those tools. but I would love to, experiment and see how these tools work, and then maybe show you in subsequent sessions that this is how this tool is working. The release phase security, the principles that is involved over here, that you are following the benchmarks, you are following the checklist, the compliance checklist, you are following the cybersecurity rules, you are following the configuration management by code. So everything should be as part of your release phase security. There are a lot of tools involved: Ansible, Puppet, Chef, Docker, HashiCorp, Terraform. Well-known tools, widely used by the industry, by the market, and that's should be part of your release phase. Okay. Monitoring phase security. Again, this is after the application is released, it's deployed to the environment. It's important to monitor the infrastructure, monitor the health of this particular program or the application, monitor the different aspect of the infrastructures. So you basically run some of the defense tools, some of the alerting tools, some of the threat security identification tools, and that's where you do monitoring is very important, right? So we put that as part of your security phase. Okay. All right. So as I have mentioned, so these are the different phases of security. You are implementing the security in terms of planning, right? You start with the planning, right? You implement the phase, you implement security in coding, you implement security in building the code, you implement security in testing the code, you implement the security aspect during the release of this particular piece of code, and you implement the security for monitoring the whole process and monitoring each of these components that is identified as part of the infrastructure, as part of the code, right? So every phase has security integrated. The last but not least, I'll give you, this is one of Azure solution architecture for implementing DevSecOps. You can see that this is a whole, you can get it from the Azure documentation. So it gives you some of these, some of the highlights that what can be done if you are building in that particular architecture in Azure. Again, components can be different, right? I'm not saying that you have to use AKS, you have to use container registry, you have to use Cosmos DB. It depends on what your application is, what your requirement is. But whatever your requirement is, it's very much important that you have different security aspect integrated to different phases of your requirement, different implementation of your requirement. So you need to have, you have to have you cannot store your connection strings, your credentials or secrets in web.config file or app.config file or something, no configuration file, right? You have to put them in some kind of a vault, right? So Azure Key Vaults, which is giving you the feature for putting all your secrets over there. You have to run the code securely in either you are doing it in a VM, in AKS, container instances, it doesn't matter. It needs to run securely, right? So that is something that needs to be understood. You have to scan those images before it is getting deployed to the related environments. Azure AD, the Active Directory, needs to be part of your implementation, obviously, because you need to authenticate the organization directory. You need to do the multi-factor authentication. You have to understand the identity protection that needs to be done so that there is no anonymous logins that can be prevented, right? The Azure Monitor and the source code monitoring. So everything is part of this architecture. You can look into that, which is using the pipelines, registry, and Kubernetes service. But you can have your own different implementation. You can have your own different requirement, but the gist of this, the baseline of this thing is that you have to consider the integration of security as part of your phases of your development. Whether it is writing a piece of code, whether it is checking that particular piece of code, whether you are testing that piece of code, whether you are building this piece of code, whether you are deploying that piece of code, or whether you are, monitoring this piece of code, monitoring your environment, monitoring your infrastructure, deploying your infrastructure, security should be part of your whole DevOps release pipeline. That's what is called DevSecOps. So with that, this is my the session ends, and hopefully this session gives you some kind of an idea what DevSecOps is. What I'm going to do is I'm going to work on some of the subsequent sessions with some of the tools to see how each of these phases can be implemented, and hopefully I should be able to share to you my experience about how these tools are working, how we can do that, and in multiple sessions. So I'm going to have those sessions together as part of this session. Thank you for your time, and have a nice day.